Okay, and welcome to section 6 in chapter 2, combining transformations. So transformations is something you have done already in Pure 1. You've done it also in GCSE, and at the top of page 44 is a reminder of all the transformations and what it does to the graph. So I want you to make sure you write that down and you memorize, if you don't already know them, what each of the transformations does to graphs. Okay, and what I'm going to look at today is some examples from the book. And some examples that I've made up. So here's my first easy example. You've got a sketch of y equals f of x, and you're asked to sketch this graph here. So this is called combinations of transformations, and you can see you've got your timesing by 3 and you're taking away 2, the two different transformations. Right, so let's first of all look at what happens when you times f of x by 3. What happens to all of my points? Well, timesing by 3, so i.e. it's on page 44, that's a f of x. So you're looking at this type of transformation. That means the whole graph stretches by a scale factor a from the x-axis. Are you pulling it this way? So my point A, when x is 2, it was 2 along, 3 up. Now it will go 2 along and it will go 9 up because I have stretched my y value by 3. So my x value stays the same, my y value is times by 3. What will happen to my b value? Well, it was 4 along minus 2 down. Now it will go 4 along minus 6 down. I think I might have to, do this on a different graph, on a different piece of paper, so you can see everything that I'm doing. So let's just do this again. So my A will go to 2, 9. My B will now go to 4 along minus 6 down. What will happen to where it crosses the x-axis? Well, they will stay exactly the same place. So this is what happens. Okay, so the whole graph is stretched by a scale factor of 3 from the x-axis. Why do these stay where they are? Well, this is nothing away from the x-axis, and nothing times 3 is nothing, so it just stays the way it is. So I have now sketched the first part of the transformation. But you are asked to sketch y equals 3 f of x take away 2. So if I'm taking away 2, what will happen to my graph is the whole graph will move down by 2. So this was 2 along 9 up, it will go 2 along now 7 up. This will go down by 2 to minus 2. So this was 2, 7. This will go down by 2. This will go down by 2 to 4 minus 8. And this will go down by 2. So my whole graph moves down by 2. So I get that picture. So if I'm just going to do one now drawing of this, it will be like this. Okay, and the key points you're asked to do is A is moved to here and B is moved to here. We're not asked to find the new coordinates, just those two coordinates, A and B. Okay, so I did that in two separate transformations. I multiplied by 3, stretched it by 3 and moved the whole graph down by 2. Okay, question. I'm asked to sketch the graph y equals f of x plus 4 in brackets plus 1. Well, let's think what happens to this. What does this do to the graph first of all? So I'm starting off, this is my function of x, and if I add 4 in brackets, what happens is my whole graph shifts 4 to the left. Okay, so like I pick it up and I shift it 4 to the left. So my y values will stay the same for a and b, and my x values will be subtracted by 4. So a will go here to minus 2, 3, and b will go here to 0, minus 2. So, and this point here would also have moved 4 across. So everything moves 4 across. In fact, yeah, so it's probably a bit more like the point A would be here. So my whole graph is going to be shifted, I'll put that point there, 4 across. I'll pick it up and move it 4 across. And this is my point A, my new point A, and my new point B. Okay, so I'm just going to draw that out again, so it's not too confusing for you. Okay, so this is B, 0, minus 2. This is A, minus 2, 3. So I've taken 4 off my x values and my y values have stayed the same. Right, the plus 1 just means the whole graph moves up 1. Okay, so if I just do that in a different colour, this time the x values will stay the same and the y values will increase by 1. So this will go to minus 2, 4. This will go here to 0, minus 1. So my whole graph is shifted up 1. Exactly the same shape, but moved 1. So this is my new A and this is my new B. Okay, it's best to do it on separate graphs and do the first transformation and then the second transformation. Okay, what about this one? These are always the hardest when you've got stretches. So let's look at f of 2x first. What does that mean? F of 2x. Well, that means that my whole graph, my original graph, f of x, will stretch in an outward direction by a scale factor 1 over 2. So this is a stretch of scale factor 1/2 horizontally. Okay, so a stretch of 1/2 horizontally. So what happens is my x values are divided by 2 and my y values stay the same. So my graph will become, so 2, 3 will come in to 1, 3. Half of 2 is 1. And 4 minus 2 will come in to 2 minus 2. Where it crosses the axis will also come in by 1/2, but then 0, the origin, will stay the same. So it's come in on itself by 1/2. It's condensed rather than stretched out. So this is my new A dash, this is my new B dash. So this is the first part of my transformation, f of 2x. Now let's look what would happen now when I put 1/2 in front of it. So I'm asked to sketch y equals 1/2 of f of 2x. Right, well the 1/2, what does that do to my graph? That will stretch it by a scale factor of 1/2 long ways. So here's my new graph. So all of my x values will stay the same and my y values will be halved. So 1, 3 will go to 1, 1.5. Or 3 over 2. 2 minus 2 will go to 2 minus 1. Because a half of minus 2 is minus 1. And so my whole graph comes in on itself. It's squashed in by a scale factor of a half. So this is my new graph. Okay? Right, that's a difficult one. Go through that again if that didn't make sense to you. Right, one more to go through before I go through a harder question. These are all the easier transformations that you have already done. Okay, you did them in Pure 1. So we're just recapping. Okay, so remember we're starting off with my function of x, and my function of x was like this. I started off with the same function of x each time. 2, 3, and 4 minus 2. That's my function of x. Okay, so I'm first of all going to look at what happens when I do this transformation. Okay, so f of x minus 1 in brackets means the whole graph shifts 1 place to the right. So 2, 3 will go to 3, 3, add 1 to my x value. 4 minus 2 will go to 5 minus 2. 0, 1, it will now go to, 0, 0 will now go to 0, 1. 1, 0. So all my x values are added on 1. So it's like this. The whole graph shifts 1 to the right. The graph stays exactly the same shape, just you pick it up and move it 1 to the right. Okay, now I'm going to look at, in fact this is made up of 3 transformations. Here are the 3 transformations. This one, I move it, the whole graph I move 1 to the left. Then I'm going to stretch it by a scale factor of 2 vertically. And then the negative sign in front of all of it means I reflect it about the x-axis. So it's useful to think of the different steps that you've got. So I've done the first step. Now I'm going to stretch everything by a scale factor of 2 vertically. So I'm just going to get a new bit of paper. Okay. So the 2 points I'm interested in are A and B. So 3, 3. 3, 3 will now go to 3, 6. So it's going to go double the distance up on the y-axis. So it'll be 3, 6. And my 5, negative 2, this is negative 2 away from the x-axis. I stretch that by a scale factor of 2. So it'll go to 5 minus 2. So the whole graph, my blue graph, is stretched by a scale factor of 2, upwards and downwards, away from the x-axis by a factor of 2. My y's are doubling. All my y values are doubling. So this point here, 1, 0, will stay exactly the same because 0 doubled is just 0. So it will stay at 1, 0. Okay, so my graph is going to now be stretched vertically upwards. So now I have my graph of y equals 2 f of x minus 1. Right, the last bit now is the negative sign, means in front of it all, means I flip it about the x-axis because everything that was positive becomes negative everything was negative becomes positive. So my graph is going to flip about the x-axis. So you imagine that as a mirror line. So my new point A, well, it's 3 along minus 6 down, and my new point B is 5 along and 2 up. So there's my end answer. Okay, now we're going to look at a harder question. If those weren't hard enough for you, this is question 18 on page 109. And why this is harder is because you've got your asymptotes in there. Now, it's page 109 because I'm looking at review exercise 1. Okay, so it's this question here, which I've written down on page 109. Sorry about that, that's my son just collapsing the vacuum cleaner in the background. Okay, I'm just going to pause the video for a second and get some, oh no, I've got paper here, I'm fine. Right, have a go yourself. This really tough one. We've got moduluses in here as well. We've got asymptotes, we've got transformations. Okay, so hopefully you've had a good go at this yourself. Okay, and we're now going to do each of these questions here in part A. So let's look at the first question. We're going to sketch y equals the modulus of the whole thing. Right, so what happens for the modulus of the whole thing? Remember this from last lesson. Everything that's beneath the x-axis will flip to become positive. So my asymptotes are going to stay exactly where they are. They are not going to change. They will not move. Okay, and everything above stays the same. Let's just do all the above first. That's all the above. Okay, sorry about that. And then everything below will flip. So you can see that the below bit here and here flips above the x-axis. So this is 5, this is 2, and my point now here goes to 1, 1. Okay. Right, the asymptotes stay exactly the same. Right, next question. You're asked to sketch y equals negative f of x plus 1. I'm going to do the x plus 1 bit first, and then I'm going to do the flipping with the negative sign second. So what happens with x plus 1 is everything, the whole graph, I pick it up and I shift it 1 to the left. Now my x asymptotes will move as well. Okay, so I'm going to have now an asymptote at 2. It was at 3, now it goes to 2. My 5 will go to 4, so this is going to be this part of the graph. My y asymptote won't be affected. Okay, so that will stay exactly the same. It's only my x values that are affected. My point 0, 0 will go here now, here. A will go to here, and so A will go now to 0 minus 1, and B will go now to 1, and my asymptote has moved to 2. So my shape of the graph will be exactly the same, it's just all moved 1 to the left. Okay, so I've just sketched, now not the plus, I've just sketched y equals f of x plus 1. Now, What happens when I put a negative sign in front of this? Well, everything is going to flip on the x-axis. So what's that going to look like? So my asymptotes are going to flip as well. Well, my y-asymptote will flip. So I'm just going to draw, this will flip, this will flip, this will flip, this will flip, and this will flip. Okay? And I'm now going to have an asymptote here. It was y equals minus 2, now it's y equals minus, so it was y equals 2, now it's y equals minus 2. So this now, the blue graph is your end answer. Y equals negative f of x plus 1. Okay, quite tricky that one. And the last one I'm going to do for this video, I'm going to look at y equals f of minus 2x. Now I'm going to first of all look at f of 2x, and then I'm going to put the minus sign in. So f of 2x will be a stretch of the scale factor a half horizontally, and the negative sign inside means reflect about the y-axis. Okay, so let's do the first bit. So let's just draw. So everything is going to come in by a scale factor of a half. So my y asymptote will stay where it is, but my x asymptote will come in to 1.5. It was 3, now it comes into 1.5. And everything else is squashed by a half inwards. Okay, half into the x-axis. So my 2, 1, my part B will now go to 1. My C will now go to 2.5, or 5 over 2. So this part of the graph will look like this. Okay. And my asymptote is at half, my x-asymptote. My naught will stay the same because naught halved is naught. And then it's going to be like this. And my point A, then my point B is 1, 0. And my point A here will be a half negative 1. Because half of 1 is a half. And here's my point C. Okay, I hope you can see all that. Just going to check that that's all okay. Yep. Right, now what happens is I've now got to reflect all of this on the y-axis. Okay. So I'm just going to try and do this on the same graph but in a different colour. So everything is now flipped on the y-axis. So my y-asymptote will stay where it is, yeah, because when it's flipped it just stays the same. My x-asymptote will flip to x equals minus 1.5. C will flip to minus 5 over 2. So this is I'll just sketch this part first. So this is this orange part of the graph flipped to here. Quite complicated, isn't it? Then this will stay the same. My point 1, 0 will go to minus 1, 0. And my point a half minus 1 will go to minus a half. So it's going to go like this, go through here, and then like that. So everything is flipped about the y-axis. Okay. So my new point A, trying to fit it on here, my new point A on my blue graph will be, it was a half minus 1, will now be a half minus a half minus 1. Okay, really tricky, that one. Right, now it's your turn. There's the work. Have a good go at that. Some really big, clear sketches like I've done. Check your answers and email me or your teachers of anything you don't understand. And I know Mr. Bennett does do some extra videos for questions you don't understand very well, which is excellent support. And don't forget, Mr. Ali is doing some extra lessons on a Monday and Wednesday at lunchtime, some live lessons. Monday and Wednesday, 1 to 3 o'clock.